Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 10 students and the topic of discussion is pair of linear equations in two variables. Let us define a linear equation. It is a polynomial in which the degree of the polynomial is 1. For a linear equation in two variables, we have taken x and y as the two variables. The equation is written as minus 4x plus 3y equal to 7. So this can be called as a linear equation in two variables, whereas this particular equation is a linear equation in one variable. Why it is a linear equation? Because the power of x here is 1 and also the power of x and y here is 1. So it is a degree of 1. Linear equation does not contain terms such as x square, y square or xy. You may be arguing that this particular equation minus 4xy equal to 7 is a linear equation, but this is not. When we multiply two linear variables or divide them, they no longer becomes a linear equation. So this particular equation is not a linear equation, whereas this is a linear equation. Now how to plot a line? For plotting a line, we need computation of 2 points. They are enough to draw a linear equation. Here I have taken one example, y equal to 2x minus 3. So which two points we should take? Here I have chosen x equal to 0, x equal to 0 and x equal to 3 as some random points in which I need to compute corresponding y. So when x is 0, y will be minus 3. Similarly, when x is equal to 3, y will be 2 into 3, 6 minus 3 equal to 3. So I have got two coordinates, 0, minus 3 and 3 and 3. So this we will be plotting in the graph paper. So I have taken 0 and the corresponding y is minus 3. Similarly, when x is 3, y is 3. Now joining these 2 points and then extending it, we get the plot of this line. Now in this particular topic we are discussing pair of lines. When we give information about one line, then it contains certain information in that. Now when we consider two equations of line, it have two pieces of information. I am giving one simple example here. For example, let x equal to age of a student and y is the age of teacher. So at present, age of teacher is 20 years more than the age of the student. So we can write this as y equal to x plus 20. So this particular equation has one piece of information. Let us assume we are given another piece of information that after 5 years, age of the teacher will be 2 times the age of the students. So after 5 years, age of the student will be x plus 5 and age of teacher will be y plus 5. So y plus 5 equal to 2 times x plus 5. So this has got another piece of information. Now we are plotting this y equal to x plus 20 by this blue color line and the second equation by the green color line. The point of intersection here gives the solution for this equation. There are two equations and two unknowns in x and y. So we require two equations for that, and through graphical method we have solved this. The point of intersection is the solution of the equation. What is the point of intersection? X is 15 here, we can go down and check, and y is 35 here. So such a pair of equation, this pair of equation which has a unique point or unique intersection point or unique solution is termed as consistent pair of equation. This is very important, students. Please note this. A pair of linear equations which has a unique solution through intersection of points by the pair of lines, it is called consistent pair of equation. What happens if the two lines are not intersecting? If they are parallel, then such a pair of equation is called as inconsistent pair. For example, this is the coordinate axis x and y, and let us draw two lines. Two parallel lines. Then the solution is inconsistent, and since they are not intersecting, they will not have any solution. Similarly, pair of equations are called dependent and consistent if the lines are coincident. Coincident means one line is lying over another. So this particular line, another line also will lie over this. So the solution is called dependent and consistent, but there will be many solutions. Since it is overlaying on the one line, all points will be possible solutions. Now, how to know whether a particular pair of lines is intersecting, parallel or coincident? Do we need to draw a graph always, or can we found through some mathematical conditions to know whether these lines are intersecting, parallel or coincident? So there are some mathematical conditions through which we can find out about the types of these three cases. Let us write the two equations or the two pair of lines by the standard notation a1x plus b1y plus c1 equal to 0, and the second line is a2x plus b2y plus c2 equal to. This is a linear equation in two variables x and y. c1 and c2 are constants. So what we find that pair of equation will be consistent and will have a unique solution where the lines will intersect by this condition: a1 by a2 is not equal to b1 by b2. a1, a2 are the coefficient of x in the two equation, and b1 and b2 are the coefficients of y. Similarly, they will be parallel and the pair of equation will be inconsistent and no solution will be there if this particular condition is there. a1 by a2 is equal to b1 by b2, but it is not equal to c1 by c2. Similarly, if these ratios are same, a1 by a2 equal to b1 by b2 equal to c1 by c2, then we will have many solutions and the lines will be coincident, means they will be lying one over another. Such a solution is dependent and consistent. Let us take an example here. Check whether the following pair of equations are consistent, inconsistent or dependent. We have two equations here. Let us find the ratios of their coefficients. So a1 by a2 is 2 by 4, which is 1 by 2. Similarly, b1 by b2 is 3 by 6, which is again 1 by 2 on simplification. c1 by c2 is minus 5 by minus 10, which is again 1 by 2 on simplification. What we observe that these three ratios, a1 by a2, b1 by b2 and c1 by c2 are equal. And as we have seen in the previous table, the pair of equations are dependent and consistent. Now, how do we solve a pair of linear equations? We already discussed the graphical method. In the graphical method, we plotted the pair of lines and the point of intersection gave the solution. Similarly, we can do algebraic method. There are two types of solution techniques. One is substitution method and the elimination method, which we will discuss now. Now consider one problem here. A two-digit number whose difference of digits is 2. The sum of this two-digit number and the number obtained by reversing its digits is 88. Find the number. So we are given information here. X minus y is equal to 2. This is from this information whose difference of digit is 2. And let the 2-digit number is xy. So x minus y is equal to 2. Now to get a number, 2-digit number, x is in the 10th place, y is in the unit place. So the number is 10x plus y. When we reverse the digits, the number becomes yx. And reversing the digit is now 10y plus x. Now when we add the two numbers, the number and its reversal, the total is 88. Now let us collect the like term. 10x plus x, 11x, y plus 10y equal to 11y. This is 88. Dividing by 11 throughout, we get x plus y equal to 8. So let us try to solve these two equations. X minus y equal to 2 and x plus y equal to 8. This we are trying to solve through elimination method. So we can cancel these two, minus y and plus y, when we are adding the two equations. So this will get 2x equal to 10, and on simplification x will be 5. Putting this equation in 1, we will get y equal to x minus 2, and substituting the value of x equal to 5, we will get y as 3. So our 2-digit number is 53. Why this is called elimination method is because we have removed one variable through basic mathematical operations such as addition and subtraction. The second method is called the substitution method, and we'll try to solve the same equations now with the substitution method. In the substitution method, we use one equation and substitute the value of that variable in another equation so that it becomes a single variable equation, and then solve it. For example, in this particular equation, x minus y equal to 2, we put x equal to y plus 2. Now we got the value of x equal to y plus 2. Now we will substitute this in this equation, second equation. So x is y plus 2 plus y is equal to 8. Now this is a expression containing y term only or one variable only. So this can be easily solved. So this will be 2y plus 2 equal to 8. 2y equal to 6, so y equal to 3. Similarly, once we substitute this y equal to 3 in this, we get x minus 3 equal to 2 or x equal to 5. So the 2-digit number is 51. Now let us take a practice problem to solve the linear pair in x and y. When we write a linear pair in x and y, it means they are the variables which need to be determined. So x and y are the variables, others are some real numbers like d, c, they are the real numbers. Now to solve this by the elimination method, we observe that in the second equation the coefficient is 1, and in the first equation it is d by c. So what we do in the second equation, we multiply by minus d by c throughout. So second equation will get minus d by cx. This term will become minus d by cy equal to 2cd into minus dc. So what happens once we multiply by minus dc by x, this particular term can get cancelled. So we are left with c by dy and minus d by cy, c square plus d square, and this cc will get cancelled, minus 2d square. So this particular thing will become c square minus d square. So c square minus d square will be on right hand side. Balance term will be c by d minus d by cy. On taking LCM inside this bracket terms, we get CD, C square minus D square, Y equal to C square minus D square. So this term will get cancelled, both are on the numerator, so Y will be CD. Now substituting the value of Y in the second equation, x plus y was 2cd, now x plus cd is equal to 2cd, so x equal to cd. So our solution is x and y both are equal to cd. This completes this chapter, friends. Now I request you to please subscribe my channel so that all future videos can be posted to you directly. And if you really like this video, please give a thumbs up so that I get motivated to make more such videos for you. Thank you very much, friends.